the interpolation, but before that please subscribe to my channel and try to watch online. The next problem is, let f of x be a given function if p of x interpolate f of x at x1, x2, 2x n minus 1, and q of x interpolate f of x at x2, x3, 2xn. I want to do two things. The first one, show that r of x equal to p of x plus x minus x1 over xn minus x1 times q of x minus p of x. Interpolate f of x at x1, x2, 2xn. This is the first thing. And the second one, I want to find r of x for f of x equal to sine of x at 3 nodal point, x0 equal to 0, x1, or let me try to write with the same notation as the problem, x1 equal to 0, x2 equal to p over 6, and x3 equal to p over 2. Okay, now let me try to prove the first part of the problem. For the first part of problem, in fact, we have to show that r at x1, x2, and xn is equal to f at x1, x2, and xn. Okay? But the critical point is that at x1 and at xn. Okay? So we have to investigate these two special cases separately, and finally we can conclude in fact our desired result. Okay, let me try to solve the problem. We know that r of x interpolate f of x at x1 to xn if r at xi be equal to f at xy, xi for I equal to 1 to n. Okay? Now, we try to show these equalities. Okay? We have to separate case I equal to 1, I equal to n, and I between 2 and n minus 1 separately. So, if I be equal to 1, so we can consider r at x1 equal to p at x1 by the definition of r, p at x1 plus x1 minus x1 plus x1 minus x1 over xn minus x1 at q at x1 minus p at x1. In fact, we use this definition for r of x, but we note that here this term is go to 0. Okay, so totally this term vanish. Okay, so this should be equal to p at x1, and by the assumption we know that p interpolate f at x1 to xn minus 1. So p at x1 should be equal to f at x1. Okay, so this is equal to f at x1. So in fact we find that r at x1 equal to f at x1, and this finish the first part of the problem. Now let I be equal to n and try to compute r at xn. This is equal to p at xn plus xn minus x1 over xn minus x1 times q at xn minus p at xn. Okay, this and this are same, so they cancel each other, so it remains just 1. So we get p at xn plus q at xn minus p at xn. These two terms will cancel, and this is q at xn. But by the assumption we know that we know that q interpolate f at x2 to xn. So this should be equal to f at xn. Okay, so we can find out that r at xn equal to f at xn. This is true. Now for the third part we have to consider I greater or equal to less or equal n minus 1. Okay, in this case we compute r at xi. This is equal to p at xi plus xi minus x1 over xn minus x1 times q at xi minus p at xi. But by assumption we know that q at xi equal to f at xi for I between 2 and n minus 1, and also p at xi is f at xi for I between 2 and n minus 1. So totally this term vanish. Okay, so this should be equal to f should be equal to p at xi, and we know that this is equal to f at xi. Okay, so the third part also works correctly. So by these three parts we can conclude that r interpolate f at x1 to xn. This is the first part of the problem. For the second part of the problem we have to compute r of x. Okay, let me rewrite r of x one more time here. This is p of x plus x minus x1 over xn. N here is 3, x3 minus x1 times p q at x minus p at x. Okay, and we know that x1 equal to 0, x2 2 equal to p over 6, and x3 is in fact p over 2. Okay, so we have to compute p and q separately, and then we join them together. Okay, so first we have to compute p of x. P of x can be computed by Lagrange interpolation. Okay, so this is f at x1 times L1x plus f at x2 times L2x. Okay, so in fact for p we use x1 and x2, just these 2 points. So f at x1 is sine of 0 times L1. What's L1? X minus p over 6 over minus p over 6, or 0 minus p over 6, plus sine of p over 6, and the other one, L2, is x minus 0 over p over 6 minus 0, right? So this is equal to, let me continue here, this is equal to, this term is 0, and this one is 1/2, and this is x over p over 6, x over p over 6, and it will be 1/2 6x over p, and this is 3 over p times x. Okay, so we get the p of x. So p of x is 3 over p times x. Keep it, and we will use in the future. Now we have to compute q of x. Let me compute q of x. For q of x, we know that q of x interpolate f at x1, at x2 and x3, right? x2 and x3. So q of x is equal to f at x2 by Lagrange interpolation formula, f at x2 times L2x plus f at x3 times L3x, and this is equal to sine of p over 6 times x minus p half over p over 6 minus p over 2 plus sine of p over 2 times x minus p over 6 over p over 2 minus p over 6. Okay, now let me continue the computation. Sine of p over 6 is half times x minus p over 2 over minus 2p over 6 plus 1 times x minus p over 6 over 2p over 6, and this is equal to 1/2 6 times x minus p over 2 over minus 2p plus 6 times x minus p over 6 over 2p. And let me continue the computation. This is equal to 3x minus 3p over 2 over minus 2p plus 6x minus p over 2p, and if you simplify these two, it will be 3x plus p half over 2p, and we can write it in this form: 3 over 2p times x plus 1 over 4. So finally we get q of x equal to 3 over 2p x plus 1 over 4. Keep it in your mind for the next, and we will use it. Now Now we can use the formula R of x equal to P of x plus x minus x1, x minus x1. In fact, x minus x over P half minus 0 times P of x, Q of x minus P of x. Let me continue in the next page. So here I have to write P of x. What it was 3 over P times x plus x minus x0. Here it should be x1. Sorry, here something wrong here. This should be 0. So x minus 0 over P over 2 minus 0 times Q of x is 3 over 2P x plus 1 over 4 minus P of x, 3 over P at x. Okay, now we try to simplify this. So this will be 3 over P times x plus 2x over P times minus 3x over 2P minus 1 over plus 1 over 4. Okay, and if you continue to computation, it will be minus 3 over P squared x2 plus 3 over P x plus x over 2P, and you simplify this term, it's minus 3 over P squared x squared plus 7 over 2P x, and in fact this is our desired polynomial for the R of x. This is a very, in fact, simple problem with both aspects of, in fact, theoretical and numerical view. So please follow my channel, subscribe to my channel, and introduce my channel to your friends. Thank you, and wait for the next lecture.